Hello learners, welcome to Dr. D.Y. Patil Vidyapeeth's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me statistics and quantitative techniques. In this video, we are going to learn decision theory, which is unit 14 of your course Statistics and Quantitative Techniques. So in this video, we are going to understand what is decision theory and what is involved in making a good decision. So decision theory involves analytical and systematic approaches to the study of decision making. So a manager can make use of various analytical tools and techniques with systematic approach to solve complex business situation with rational and efficient decision making. A good decision is one that is based on logic, considers all available data and possible alternatives and quantitative approach described here. So, you know, a decision maker should consider all the available alternatives before choosing one. It involves using all the available information. It is based upon the usage of logic, then it is based upon the use of analytical abilities and available alternatives. There are 6 steps in decision making process. So these 6 steps are: number 1, clearly define the problem at hand and list all possible alternatives. So number 1 is clearly define the business situation or business problem. So this is the first step in decision making process, that a decision maker should be able to define the problem in accurate terms. The second step is list the possible alternative. So the second step is understand and list out all the possible courses of action or alternatives available to a manager. Then in the third step, identify the possible outcomes or states of nature. So identify the outcomes, payoffs, or we can say the output of choosing alternatives and states of nature. Then list the payoff or profit of each combination of alternatives and outcomes. Then in the step 5, select one of the mathematical decision theory model. And number 6 is apply the model and make your decision. Now let us consider an example of Thomson Lumber Company. So we are taking a case. So in step 1, as we have discussed, we need to define a problem. All business manager decision makers have to define the business problem which has roots in a particular business situation. So here, as per as Thomson Lumber Company is considered, the problem is they expand by manufacturing and marketing a new product. So the company wants to expand, and the way of expansion can be manufacturing and marketing a new product. Backyard storage sheds. Step 2 is listing all the alternatives. So what are the different courses of action available to a manager while making a decision? That is what alternatives. So the alternative courses of action are: construct a large new plant, construct a small new plant, and construct no plant at all. So these are the 3 alternative courses of action available to a decision maker with respect to the problem. Then number 3, step 3 is identify possible outcomes. So what would be the outcome or states of nature of each course of action? So that is what outcome is. So identify all possible outcomes. So the market could be favorable or unfavorable. So there are 2 situations. Either the market is favorable or unfavorable. So according to that, the payoff, that is the outcome of each course of action, would change. Then step 4 is list the payoff. Payoff means outcome or output of choosing any particular course of action. So identify conditional values for the profits for large, small, and no plants for the 2 possible market condition. Then step 5 is select the decision making model. So depending upon the environment and amount of risk and uncertainty, a decision making model is chosen. Step 6, apply the model to the data. So we have to apply the model and we have to generate the solution by using the model. So solution and analysis used to help the decision making. Thomson Lumber Company. So we have alternatives, as we have already discussed in the decision making process or steps in decision making, that the problem is the lumber company, the Thomson Lumber Company, is planning to expand the manufacturing and marketing of a new product, right? And the courses of action available to a decision maker are: construct a new large plant, construct a new small plant, and do nothing. These are the various options or alternatives available to the decision maker in this particular case. So what are the states of nature? States of nature consist of payoffs, that is outcome of each course of action or alternatives available. So there are two situations: either the market can be favorable or the market can be unfavorable. So if the market is favorable and if we construct a large plant, the payoff is 2 lakh. And if the market is unfavorable and if we construct a large plant, then the payoff is minus 1,80,000 dollar, or we can consider in the rupees also. Then if we construct a small plant and market is favorable, the profit or the payoff is 1 lakh. And when we construct a small plant and the market is unfavorable, then in such case the payoff is negative 20,000. And if we choose to do nothing, then even if the market is favorable or unfavorable, it doesn't matter, and the payoff is 0. Types of decision making environment. So there are 3 types of decision making environment: decision making under certainty, decision making under uncertainty, and decision making under risk. So let us discuss the decision making environment in brief before we understand various types of decision making model available to a decision maker. So type 1 is decision making under certainty. So decision maker knows with certainty the consequences of each alternative or decision choice. So in case of decision making under certainty, decision maker knows with certainty. So he has perfect certainty that the consequence of every alternative and decision choice. So we know the payoff and profit of each alternative chosen by the decision maker with certainty. Then the second type of decision making environment is decision making under uncertainty. So the decision maker does not know the probabilities of various outcomes. So there is uncertain. And the third type of decision making environment is risky environment, decision making under risk. So in this case, decision maker knows the probabilities of various outcomes. So whenever in previous business situations, we have applied or implemented some courses of action or some alternative solutions. In such cases, from historical data, we can know the probabilities, right? So such kind of business environment is called as business making under risk. And when we haven't carried out or when we haven't implemented some courses of actions or alternative solutions, then we do not have the data regarding the past performance or past payoffs of such alternative courses of action, and therefore the decision making becomes under uncertainty. Decision making under uncertainty. So there are 5 tools we are going to learn under this decision making under uncertainty. So there are several criteria for making decision under uncertainty. The criteria are maximax, so this is optimistic approach. Then maximin, this is pessimistic approach. Then there is a criterion of realism, this is known as Hurwitz criterion. Then equally likely criteria, so this is Laplace criterion. Then minimax regret. So we are going to discuss and learn all of them one by one. So maximax criterion. So we have alternative: construct a large plant, construct a small plant, and do nothing, no plant. Then we have states of nature: favorable market, unfavorable market, and accordingly we have payoffs for different courses of action. Now in maximax, what we do? So we choose the maximum from each row. So for the first course of action, that is constructing a large plant, we have two payoffs for favorable market and unfavorable market. So for favorable market it is 2 lakh, and for unfavorable market is 1 lakh 80,000 negative. So the maximum is 2 lakh. For constructing a small plant, the maximum is 1 lakh, the maximum payoff I am talking about, irrespective of the states of nature. And if we choose to do nothing, the maximum is 0. So this is maximax criteria. So we choose maximum of maximum value. So we have taken maximum values here from each row, and out of these three values we have chosen the maximum value. This is maximax criteria. So this is used to find the alternative that maximizes the maximum performance. So locate the maximum payoff for each alternative. So we can find out the maximum payoff for each alternative on the right hand side. In the last column you can see, and select the alternative with maximum number. So we find out maximum from each row, and then we chose the maximum from the last column, and it is 2 lakh. So it is maximax criteria. So it is the optimistic approach. Then we have maximin criteria. So what we do here, we select the minimum from each row. So for constructing a plant, we have different payoffs, 2 lakhs and minus 1 lakh 80,000. So we choose the minimum, which is minus 1 lakh 80,000. Then constructing a small plant will have two possible payoffs, 1 lakh and minus 20,000. The minimum is minus 20,000. And for doing nothing, the payoff is 0, 0, the minimum is 0, right? And we choose maximum of these minimum values. As you can see on the right hand side, the minimum values were minus 1 lakh 80,000, minus 20,000 and 0, and we choose the minimum of these three values, which is the maximum of these three values, which is 0. So this is pessimistic approach, right? So we take minimum values of payoffs, and then we choose maximum of them. So this is what a plant, a firm or a decision maker expect in the difficult times or in the pessimistic manner. So locate the minimum payoff of each alternative, select the alternative with the maximum number. So this is how it is done. Then criteria of realism, that is Harvey's criteria. So a weighted average compromise between the optimistic and pessimistic. So the maximin criteria is a pessimistic approach. So it considers that something wrong will happen and we would not be able to achieve the best possible profit, and that this is a pessimistic approach, maximin. The maximax approach was optimistic. It is based upon the consideration that everything will go right and everything will go as planned. The market will remain favorable and nothing will happen wrong. So this is maximax criteria, optimistic approach. And the Harvey's approach is in between. So a weighted average, and it is a compromise between optimistic and pessimistic. So we need to select a coefficient of realism, which is alpha, given by Harvey's, and we need to the coefficient has to be between 0 and 1. If the value of this coefficient is 1, it is considered as 100% optimistic, and this will be equal to maximax. And if the value of the coefficient of realism is 0, then it is 100% pessimistic, and the value will be equal to maximin. So depending upon the value of the alpha, the payoff will vary. So compute the weighted average for each alternative. Select the alternative with the highest value. So weighted average is equal to alpha multiplied by maximum in a row and plus 1 minus alpha minimum in a row. So this is how we are going to calculate it. So for the large plant alternative, using alpha is equal to 0.8. So we are using alpha is equal to 0.8. So if we use alpha is equal to 0.8, we have to multiply the maximum value in a row by 0.8, right? So 0.8 multiplied by 2 lakh plus 1 minus 0.8 multiplied by the second payoff for constructing a large plant, which is minus 1 lakh 80,000. So when we calculate it, we get 1 lakh 24,000 as the criterion of realism, right? So 1 lakh 24,000. Then when we construct a small plant, 1 lakh multiplied by 0.8 plus 1 minus 0.8 multiplied by minus 20,000, and this will give us 76,000. and when we choose to do nothing, it will remain 0. So we choose the maximum value of the last column, which is 1,24,000, which is the Harvey's criteria. And according to this particular criteria, constructing a large plant is the best solution. According to the previous rules, according to the maximum criteria, doing nothing is the best solution, right? Because this is a pessimistic approach, and according to it, there would be a loss of minus 1,80,000, and market will be unfavorable. And if we construct a small plant, there will be a loss of minus 20,000, and if we choose to do nothing, there will not be any loss or any profit. So this is the best solution as per the maximum criteria. As per the maximax criteria, the best solution is choosing to construct a large plant, because the maximum payoff or the profit available is 2 lakh from this particular criteria under optimistic conditions. Now we have Laplace criterion, and Laplace criterion is applicable when equally likely. So we consider that both of them are equally likely. So what we do here, consider all payoffs for each alternative, find the average payoff for each alternative, and select the alternative with the highest average. So basically we calculate the average here, or you can take alpha is equal to 0.5, you will get the same result. So this is equally likely criterion. So 2 lakh plus 1,80,000 minus 1,80,000 divided by 2 will give us 10,000. So let me calculate it here. So average of payoffs when we choose to construct a large plant is equal to 2 lakhs plus minus 1,80,000 divided by 2. So this is how we calculate the average, because there are two values, addition of these two values divided by the number of values, that is 2 in this case. So 2 lakh minus 1,80,000 is 20,000, divided by 2 is 10,000. Similarly, we calculate the Laplace criterion for equally likely, Laplace criterion for the choosing a small plant. So 1 lakh plus minus 20,000 divided by 2 will give us 40,000, and for doing nothing it will be 0. So we choose the maximum value from the last column, which is 40,000. So when we consider Laplace criterion, the best solution is constructing a small plant. Then minimax regret. So based upon the opportunity loss or regret, the difference between the optimal profit and actual payoff for a decision. So in this, we have to create an opportunity loss table by determining the opportunity loss for not choosing the best alternative. So whenever we choose some other alternative other than the best alternative, there will be some opportunity cost. So that we consider in minimax regret. So opportunity loss is calculated by subtracting each payoff in the column from the best payoff in the column. Find the maximum opportunity loss for each alternative and pick the alternative with the minimum number. So that is what we are going to done in minimax regret. So what we do, payoff of choosing the best alternative, the maximum is 2 lakh. So 2 lakh minus 2 lakh, then it is 0 minus 1,80,000, right? So then 2 lakhs minus 1 lakh. If the market is favorable, let me elaborate on this. If the market is favorable, the best alternative is 2 lakhs, right? The best alternative is 2 lakh. Choosing to construct a large plant. So the best alternative is choosing to construct a large plant. So when we consider, a large new plant, then in case of favorable condition, the opportunity cost or opportunity loss will be 2 lakhs minus 2 lakhs. The opportunity loss when we choose constructing a small plant would be 2 lakh minus 1 lakh, because the best alternative is choosing a large plant, constructing a large plant, and when we choose to construct a small plant, there will be a loss of 1 lakh. And the third alternative is doing nothing, and the best alternative is 2 lakh. So the payoff loss or the opportunity loss is 2 lakhs minus 0. And for unfavorable situation also we calculate it similarly, right? Because yes, so alternatives: constructing a large plant, construct a small plant, and doing nothing. and the favorable market. So these values are taken from this. 2 lakhs minus 2 lakhs is 0. Then 2 lakhs minus 1 lakh is 1 lakh. 2 lakh minus 0 is 2 lakhs. Then 0 minus 1 lakh 80,000 is 1 lakh 80,000 when the market is unfavorable, and when we choose to construct a large new plant, then then the states of nature would be 1 lakh 80,000. So similarly 0 minus 20,000 is 20,000, 0 minus 0 is 0, right? So this is the opportunity loss table. And from this opportunity loss table, what we are going to do, we are going to calculate minimax regret. So here we calculate minimax regret. What we do here, we choose the maximum value from each row. So 0 and 180, 180 is the maximum value. 1 lakh and 20,000, 1 lakh is the maximum value. 2 lakhs and 0, 2 lakhs is the maximum value. So here we choose minimum of these maximum values. So these are maximum values in the last column, and we choose minimum of them. This is minimax. So 1 lakh is the minimax regret. Then decision making under risk. So decision making under making when there are several possible states of nature, each of with different probabilities, is decision making under risk. So most popular method is to choose the alternative with the highest expected monitor value, that is EMV, expected monitor value. So EMV of choosing alternative 1 or I is equal to payoff of the first state of nature multiplied by probability of first state of nature plus payoff of second state of nature multiplied by probability of second state of nature plus probability of last state of nature multiplied by payoff probability of last state of nature. So each market has probability of 0.50. So whether it is favorable or unfavorable, probability 0.5. So which alternative would give the highest expected monetary value? So the calculation are as below for our Thomson-Lumber case. So EMV for choosing a large plant. So 0.50 multiplied by 2 lakh plus 0.50 multiplied by minus 1 lakh 80,000. So EMV for choosing large plant is 10,000 expected monetary value. Then EMV for small plant is equal to 0.50 multiplied by payoff under favorable condition plus 0.50 multiplied by payoff under unfavorable condition. So this will give us 40,000 EMV for small plant. Then we have EMV for doing nothing. Then 0.50 multiplied by 0 plus 0.50 multiplied by 0, this will give us 0. So these are the EMVs from different courses of action chosen. So the same table is taken here. So 2 lakh minus 1 lakh 80,000, 1 lakh minus 20,000, 0, 0. These are the probabilities. And this 0.50 multiplied by 2 lakh, 0.50 multiplied by 1 lakh 80,000, addition of these two will give us 10,000. Similarly, 0.50 multiplied by 1 lakh plus 0.50 multiplied by minus 20,000 will give us 40,000. And then for the final option, that is the last option, doing nothing, 0 multiplied by 0.5 plus 0 multiplied by 0.5 will give us 0. So the largest value in the last column is largest EMV, and according to the EMV, that is EMV criteria, the best solution is to construct a small plant. Then expected value with perfect information. So this is also a model under decision making under risk. So EVPI places an upper bound on what you should pay for additional information. EVPI is equal to EBWPI minus maximum EMV. So maximum EMV we have calculated in the previous example, previous case. Now what is EVWPI? So EVWPI is the long run average return if we have perfect information before a decision is made. So what we do, how do we calculate EVWPI? EVWPI is equal to best payoff for the first state of nature multiplied by the probability of first state of nature plus best payoff from second state of nature multiplied by probability of second state of nature, and so on. So expected value with perfect information EVPI scientific marketing inclusive offers analysis that will provide certainty about market condition, whether it is favorable or unfavorable. So market forecasting, scientific market will help you to understand whether the market will be favorable or unfavorable. Additional information will cost 65,000. So this forecasting cost will be $65,000 or rupees 65,000. So is it worth purchasing this information? That is understood through EVPI. So the best alternative for favorable state of nature is build a large plant with a payoff of 2 lakh. So best alternative is choosing the large plant. Best alternative for favorable state of nature is to do nothing. Best alternative for unfavorable state of nature means the payoff is 0. So it is doing nothing. So EVWPI is equal to 2 lakh multiplied by 0.5 plus 0, that is the payoff for choosing nothing. So 0 multiplied by 0.50. So this is equal to 1 lakh. So EVWPI is equal to 1 lakh. The maximum EMV without additional information, which we have calculated in the previous case, so which is 40,000. Then EVPI, that is expected value of perfect information, is equal to EVWPI minus maximum EMV. So 1 lakh minus 40,000 is equal to 60,000, and we purchase the information at $65, and therefore the purchase of so the maximum Thomson should pay for additional information is 60,000, and if someone quotes that the information will be provided at $65,000, then you should not purchase that information. So that's all about decision theory. I hope you have understood all the concept, all the models of decision theory, and you would be able to apply to solve various business situations by using these concepts. So thank you for watching this video. Thank you all.